Hello guys, welcome back. In this video, I'll teach you how you can write C# code from a beginner's point of view to the point that you can actually create your own application, right? So before I just get started, C# is an object-oriented programming language created by Microsoft that runs on the .NET framework. C# has roots from the C family, and this language is close to other popular languages like C++ and Java. The version was released in 2002. The first version was released in 2002. The latest version, the C#A, was released in September 2019. C# is used for creating mobile application, desktop application, web services, websites, games, DL, databases, and much more. So rather than just wasting your time, I will actually speak briefly on why you should choose C# as a starting language. It is one of the most popular programming languages in the world. It is easier to learn and simple to use. It has a huge community support. C# is an object-oriented language which gives a clear structure to programs and allows code to be reused, lowering development cost. As C# is close to C, C++, and Java, it makes it easier for programmers to switch to C# and vice versa. So how do you get started? You get started by first having something called an IDE. An IDE is integrated development environment, allow you to edit your code and compile them. So in this video, we'll be using a Visual Studio as our IDE. So it's very important that you know what that is. So I'm just going to open this page, yeah. So I have this web page on here. This is where this is the website that you would have to come if you want to if you want to download a Visual Studio. And the latest version is the 2019, the time I'm doing the video. So code fast, you see the motto, code faster, work smarter, create the future with the best in class IDE. So you go ahead and download this if you don't have it. They have free categories. The community version, which is free, the professional, which you're gonna pay something, and the enterprise one, you're gonna pay something as well. So you should bear that in mind. So I mean, after going through all your installations, I've got a video on that, so I'm not going to emphasize too much on it. So you can watch the video and just come back to this video again. So what we do is just going to create a very simple application. We're going to create a very simple application, and then we actually going to work our way up. So to get started with the C# language, you're going to have to create a new project. So once you open the Visual Studio, you'll be prompted with this dialogue, a dialogue like this saying, what would you like to do? So here you can clone or check our code from like a repository. You can open a solution or a project. You can open a folder, or you can create your own new project. So we will go ahead and create our new project here. So once you click on that, you'll be prompted with like different types of project templates that you can get started with. Yeah, here you can choose what language you want to use. There are a couple of languages here that you can use. So we select our C# with a C hashtag sign, and the platforms, we can select all platforms and all projects, right? So what we do is we're just going to select the console application, right? I've got one here as a recent project, so we're just going to open that one. So I'm just going to close this bit here. So as you can see, I have once you create the first console application, you C#, I mean Visual Studio adds a couple of files to it to get you started, and there's a property folder which you can actually you have a look later on, but I'm just gonna. This is where you can actually put your configurations, like, you know, as you can see, the property has got lots of stuff. You look at it separately later on. We're not going to emphasize too much on it. So I'm just going to close it, but I just wanted to show you. And then we have the reference or references. The references are just external libraries that will make that you can add to your project to work. I mean, the role is the system. I mean, the system, and this is the language reference. So as you can see, there's a whole lot of references that we will make use of later on the later video. So we're not gonna emphasize too much on this. And then we've got our configuration file. We're not gonna look at all, but we're gonna look at this the program.cs, and every C# code or application or file ends with a .cs so it's a .c#. So just bear that one in mind as well. So this code is normally created with something inside, but which never came up. So I'm just gonna write it something here, but I will explain it later on. So don't really worry too much about that. I have written a console.writeLine. I will explain that later on. So we're gonna put hello world here. So I will start from the top explaining this file because it's very important to understand this for the first time. Here, as you can see, we have a using keyword system. So if we are going to add something or an external library or external DLL into our program or into the file here, this is how you reference it. You reference it by using the keyword using and then the name of that reference you want to. In this case, we are referencing the system. So if we come inside our references here, you have this system here. So this is exactly what we are referencing. Yeah, so as you can see, now we've got most of the references with the light off. In this case, what this shows is we are not actually making use of these references. That is why you see the light is on. It's very whiter than the rest. It means we are using it. We've actually referenced it. So if we remove it, here, so as you can see, the system is gone. It's off now. So once we put it back, you see the light is back on again. So it means we are actually the console is under the system namespace. So we should also bear that in mind. So I will continue to explain the whole thing. But before we continue, I'm gonna run it just to see what comes out of it. And to run it, you can press this bit here, the start, or you can use the F5. They're all going to do the same thing. So as you can see, once it runs, it switched off straight away. So we can actually put something like that here, something like this here, console.read key, and we set that to true. So once we set the interceptor to true, it will actually prevent the console from closing so that we can see what actually came out of it. So as you can see, we have a hello world printed, right? So basically, the console.writeLine, this is to write a text to the console, right? So I'm just going to explain that further as we go on. So since we've actually run our first program, we go ahead and I'll go ahead and explain it line by line. Okay, so the line one, which I've actually explained, which is the using namespace. Okay, so the line 4 is a namespace console application, console app 7. The namespace, yeah, is used to organize your code, and it is a container for classes and other namespaces. So after the namespace, we have a curly braces. So the curly braces marks the beginning and the end of a block of code. So we should bear that in mind. So right after the curly, we have a class program. The class is a container for data and methods, which brings functionalities to your program. Every line of code that runs in C# must be inside a class. In our example, we named the class program, or we have a class program. So don't worry too much if you don't understand how using system, namespace, and class works. You'll get to understanding more as we go on, because there's something that you cannot escape. We'll be using it a lot. So the next part is obviously the static void main. So the thing, the main method code, the main method is the entry point right now to our to this application. This is where the application starts. So it start by calling this main method, and then it reads from top to bottom. So we should also bear that in mind that C# code reads from top to bottom, right to left. I mean left to right, top to bottom. Okay, so now we've actually looked at the main. Let's have a look at the console. The console is a class of the system namespace. So which has a method called writeLine. The method is used to This method writeLine is used to output or print text. In the example below, we have the output as word hello world. So we actually said we told the console that we want to write a new line called hello world. So basically this is the meaning. So if you omit the system line, you have to write system.console.writeLine instead. So we actually use this using system just to prevent ourselves from having to write the system all over again. And then the C# statements ends with a semicolon. So as you can see, this is a statement that is actually commanding the console to write hello world, and it ends with a semicolon. Same as the read key ends with a so in C#, every statement ends with a semicolon. So if we leave it like this, you see we will get an error. We will get an error straight away, prompting us to actually add a semicolon. Okay, also bear in mind that unlike Java, the name of the C# file does not have to match the class name, but they often do. When saving the file, save it using a proper name and add the .cs extension, like I said earlier on, to the end of the file name. To run the example above on your computer, make sure that C# is properly installed. Go to the get start. You should look back to. If you start with this video, then you know how actually we actually install the whole thing. Or you can actually consult one of my videos, which I've got the full video on how to get started with it. So we have a look at the writeLine. Alright, the most common method to output something in C# is writeLine, but you can also use the write. The difference is that the writeLine prints the output on a new line each time, while the right prints on the same line. Note that um, you should remember to add spaces when needed for better readability. So we will get to that so later on. So, but what I'm gonna do is, see, I'm gonna leave a space here. I'm gonna remove this and just leave hello. I'm gonna go down to the, and I'm gonna write console.write. Console.write, yeah. And then I'm gonna say, I'm not gonna say it, but you can tell by what I've written now. Yeah. So I'm just gonna run it again. You can run it by just clicking the start, or you can use the F5. So as you can see here, hello monkey's world. You see it. So this has taken a new line here, because the right line always takes a new line. So I'm just gonna make one quick example again. Yeah. So instead of using the right line, yeah, we're just gonna use the right, both right, yeah, and we see what's gonna happen. You run it again. So as you can see, so it's actually appended to two text messages instead of just writing both of them in new lines. They've actually been concatenated together. So you can see how it all works out. Yeah. So I'm just gonna close it again here. So what we're gonna do next is I'm gonna explain what is comments or commenting in our C# language. Yeah. Comments can be used to explain the C# code and to make it more readable. It can also be used to prevent execution when testing alternative code. So there are single lines and multi-line comments, right? So what I'm gonna do is just the single line, yeah, is used with a two forward slashes, yeah. So this is how you write a comment. So we say console write, yeah, is for writing text to the console on the same line. So as you can see here, you see that the comment is actually coming on green, and once the compiler reaches this side here, what it does is it just skips to the next line. So it doesn't read it, it just skips. So basically, this is how you can write a single line comments. But there are also ways that you could actually write multi-line commenting. But before you do that, you know the comment line, you can also comment to prevent the setting code from running. So in this case here, we have the two console.write here. If we want one of them to stop running, so in front of it, we're just gonna put a double quote, yeah. And as you can see, it's been turned into a green. That means the compiler will skip it when it gets to that side. We run it to see if that side runs. Yeah. You're gonna run it by clicking the F5. So as you can see now, we've only got the hello. Hello. If we come to the code, you see that the monkey's world is commented, so we only get the hello. So that is how it all works out. But we will actually add more stuff to it as we go on. So I'm just gonna stop the console from running. So now, what I'm gonna show you next is I'm just gonna copy this bit here. So now we're gonna need a multi-line test. So it's just a forward slash that and forward slash that, and then that forward slash. So anything in between here, you can add your comments. See? So now you can add multi-line comments, and whenever the compiler reaches this side, it will skip all the way to this bit here and then start running the console.write. So that is how you also write the multi-line commenting. And you can also look at, so now we understand some basic stuff here. Let's get to the real deal in a bit way here. So you look at variables in C# here. So I'm just gonna remove this bit to just this side. So we look at the variables in C#. Variables are just containers for storing data values. In C#, there are different types of variables defined with different keywords. For example, an int, which is int, stores integer values or whole numbers without decimals, both the negative and the positive one. So we can say we can, and then double stores floating point numbers with decimal, such as 19.99 or minus 19.99, and the character stores a single characters, such as A, B, but the char values or char or character values are surrounded by just a single quote. So we can also write the character. So the character value, this is how we store it. We write it, it's just char. So that is the character, right? So, and we have a string. And the string stores text, such as hello world that we actually did. And string values are surrounded by double quotes. Yeah, so the characters are single quote and the strings are double quotes. So bear that in mind. We'll look at that later on. And if you may recall, the hello world, I put that in a double quote, yeah? Then we have a boolean or a bool, which can be written as a bool or boolean, both, any of them works. Stores values with two states, true, either true or false. So declaring and creating variables. To create a variable, you must specify the type and assign it value. Yeah, so it's more like the type and the prefix or the name you give to the type, and then the value. You see, that is how you put it. So equal to will give you the value. So instead of the type writing exactly a type, we can just say an integer, which is a type, and then we can put the value, and then we end that statement with a semicolon, like we actually stated earlier on. So in this case here, we have it initialized. We've created an integer variable and given it an initial value of 10. Yeah. So we should also bear that in mind. So where the type is a C# type, such as integer or string, a variable name is the name of the variable, such as X, or the name. The equal sign is used to assign values to the variable. So this equal to sign is actually assigning the value 10 to the int type. So to create a variable that should store text, look at this is very simple. In C#, the text can be represented in string. So we can say st, and then we can assign it with a value. So we can just call it John. So as you can see, it's a very simple stuff here. And then even now we can actually we can write st for a test. In this case, we are actually printing out the value of this string st into our console. So once we run it, we should have the value of the string st. As you can see, we've got John printed out. So John is a value of the string we created st. So we should bear that in mind. And then, as we all know, we've got an integer here. So we can actually also print out the value of our integer, the TP. It's the same thing. So we run it, we get the value printed out, not the name of the type. So we should get the value number 10 here. That's fine. Then there's one more thing that we could do. So once we declare the TP to be 10, we can also come all the way down the code here, and we can also say TP is equal to 400. So as you can see, we've actually changed the value of the TP. Yeah. So you see the compiler is telling us that the value assigned is not used in any execution path. So this actually become redundant. So in this case here, once we run it, we get the value TP printed out instead of the 10. I mean, instead the value 400 instead of the 10. So in this case, we could actually remove it here and just put the semicolon here, and it still works out. So as you can see, it's a very simple stuff. Then there's one more thing variable that we will need. So in this case, as you can see, we changed this bit here and still printed it out. But there are some certain instances that we need the number to be constant, whereby no one should be able to change it. So if that is the case, then we can use the constant with a variable keyword const, as in const. So as you can see, we have assigned the TP to 400 here. But if we make the TP from the declaration side part as a constant, then we should get an error here. So in this case here, the TP becomes read only. So you will not be able to modify it. So once we put the cursor on that here, you see the left hand side of an assignment must be a variable, property or an index. Local constant TP is immutable. The assignment target must be an assignable variable, property or an indexer. So as you can see, so once we put that const here, we render our variable mutable. In this case, it cannot be changed. So what is this important? You know that like in some circumstances, yeah, you would have a number that you wouldn't dare to change. Like let's say the value of a pi. See, that's something that you should remain the same all the time. So we could use the constant to actually denote that, so that no one will be able to change it. Okay, so like in C#, there are other types. Now, as we can see, we've actually looked at an integer and a string. Yeah, but there are some other types. Yeah, so there's that integer num, which we can set the value to whatever we want, and then close the statement with this. And then there's a floating point number as well. Floating point number, so we can also set that that's a decimal with an F. So as you can see, FT, we have to always give the name. Once we declare the variable, we have to give it a prefix. We have a char for a character, ch. So once we see that, as I said, the character is a single quote, yeah. Then we've got the boolean. is true, then we can set it to whatever. Boolean is true. Then we've got our string, which of course we've actually looked at. So as you can see, the string st uses a double quotation. So I wish you bear that in mind. So as you can see, these are the most primitive C# um, variables or keywords. So this last part, yeah, we look at displaying a variable inside our console. So it is very simple that we give this a name. Call him Johnny Be Good. Yeah. So Johnny Be Good. This is how we can print out the name of Johnny Be Good inside our console. So basically now we're using a C#8 here. If you're using the latest version of the Visual Studio and using C#8 here, then you can easily do it as starting it with a $sign. It opens a double quote for you, and then you can say username, and inside the double quote here we can put a curly. So here we can put our st inside. Yeah, so this is how we're gonna print it out. So we can just print out it. You see the username Johnny Be Good. So we've actually been able to print out the variable inside into our console. Yeah, and we could even if we can even add the age. We can make the integer as an age. So we can add it, and it's so we can just say age years old. So run it again, and as you can see, we're going to get the string st printed as well as the age, the integer age. So we run it again. So as you can see, a username Johnny Be Good and 20 years old. So it's very simple stuff. We could have said and he's, but it's not really important. What is important is being able to understand why we actually put this in the curly brackets. And it's all just to show a variable, this local variable inside the text. So you move forward. So we can actually, before we go on, we can actually define multiple variables, yeah, on the same line, if you get what I'm saying. So let's say an integer age, yeah. We could say remove this bit here, and instead of the semicolon we can put a comma here. Then we can say C is equal to 4, and put another comma. X is equal to 43, and then we can close it. So what we just done here is we've actually added multiple integers on the same line. So we can call X and it will pops out. Instead of the age, we can call the C and it will pop up. So if you get what I'm saying. Yeah, so as you can see, it's a pretty simple step. We could also do the same thing to the string as well. So we could just puff it up here, give another variable, set it up. See, and then there we go, and then we can go on and on and on and on and on. So I hope you understand this bit here. So I will actually, before I go on to the next bit, I would say that all C# variables must be identified with unique names. It is very important. As you can see here, I used C. I did not use C again because they cannot be the same, because this is a different variable from this one and from this one. So all different variables should be uniquely identified. Identifiers can be short names like X and Y, or more descriptive names like age, sum, total, volume, whatever. It is recommended to use the descriptive names in order to create understandable and maintainable code. The general rules for constructing names for variables are: names can contain letters, digits, and the underscore character. Names must begin with a letter. Names should start with a lowercase letter, and it cannot contain white space. Names are case sensitive. In this case, this variable int x is different from int s. See, they are all two different variables, right? As you can see, I'm getting this error because I've already defined it here. That's what I'm saying. We have to always use any unique names. So you have to remove this bit here, and now we have it here. So as you can see, the small x and the big x, they're all different variables. So variables are case sensitive, so you should bear that in mind. And there are some reserved words like keywords such as the int, double, bool, and a lot of them cannot be used as names. So we'll go ahead with our video. And here now we look at the data types in C#. Yeah. C# has got a lot of more primitive data types, which we've actually looked at most of them here. The integers, your strings, and whatnot. I'm gonna remove this bit here. A data type specifies the size and type of variable values. It is important to use the correct data type for the corresponding variable to avoid errors, save time and memory. But it will also make your code more maintainable and readable. The most common data types are an integer, which is a 4 bytes, yeah, and stores the whole numbers from minus blah 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 to like some huge numbers. Yeah, I'll print them out later on. And we have a long, which is also an integer, which is a big integer value, which takes 8 bytes, which with the size of 8 bytes, and stores the whole numbers from 9, like a lot of value. I'll print that one out as well. And we got floating point. This stores fractional numbers sufficient for 6 to 7 decimal digits. And we got double, which is 8 bytes, stores functional numbers sufficient for storing 15 decimal digits. We got a boolean, which is a byte, stores true or false values. We got char for character, which stores 2 bytes, stores a single character letter surrounded by single quotes. And a string which is 2 bytes, stores a sequence of characters surrounded by double quotes. So number types are divided into 2 groups. Yeah, the integral types and the floating point types. Yeah, the integral types stores whole numbers, positive and negative, without decimal valid types, or without decimals. Valid types are int and long. Which type you should use depend on the numeric value. The floating point types represent numbers with a fractional part containing one or more decimal valid types, or float and double. Even though there are many numeric types in C#, the most used for numbers are int for whole numbers and double for floating point numbers. However, I will describe as we continue some other ones. Integer types, yeah. I will I will explain most of them as we go on the next videos, yeah. So we move on to the next stage. Okay, so this part here, we'll go ahead and look at typecasting. Typecasting is where you assign a value of one data type to another. In C#, there are two types of casting. The implicit casting is automatically converting a smaller type to a larger type size, like a char to an integer, int to long, and long float to double. Explicit casting, that's manually converting a larger type to a smaller size type, like double float, long, int, and character. So we look at implicit casting. Implicit casting is done automatically when passing a smaller size type to a larger size type. Yeah. So we're gonna have an integer t to be of the value 9 or 10. Then we've got a double d to be equal to t. So this is an automatic casting int to a double. So now we could actually write our double, which is d, to the console, and that should print out the value 10. So as you can see, so the double value is now the value t. So it's just a very simple way. Then here we're going to look at the explicit casting. So explicit casting. Casting must be done manually by placing the type in parentheses in front of the value. So we're going to say double d is equal to 10.20, 10.49. So now we could just say int t is equal to, and then we can put the integer in the parentheses here. That means we are actually explicitly casting the d to an integer value. So now we can actually print out the t. So we just wait for that to compile. So as you can see, it's converted back to an integer 10. But you see, it's 10.49. I did that intentionally. I'm gonna make it 10.50. You see what value will come out. 10.50. See that is still 10. You make it 10.670. You see, that's still 10. So the reason why I did that is, when you convert it here, what it does is it trims off the decimal point and just take the whole number. It doesn't round it up to the next whole number. So you should bear that in mind. So the next thing is a type conversion methods. So it is also possible to convert data types explicitly by using a built-in method such as convert. A built-in class such as convert. Yeah. So I will explain that one as well. So we're gonna say we're gonna have another console.write line here. We're gonna say please enter your name. Please enter your age. Yeah. So we're gonna say int age is equal to convert to, see, as you can see, as we put the convert to, you see all the data types that you can actually convert to. So in this case, we're going to convert to an int 16 or int 32. Yeah. So what we do is we put the console that's read line. So this will read our input. I will explain that on the later videos. Yeah. So now we can just say, we can just put the age inside the curly. Okay, we can just put a dollar sign, just say your age is, then you can put the age. So now you can run it again. So as you can see, enter your age. So we're just gonna enter your age. So as you can see, your age is 64. So we've been able to convert it by using the building type or building methods. By converting the console.read line always returns a string. So that is a string. Yeah, as you can see, it's a string. So we actually converted our string. So the age we entered is a string, so we converted it into an integer value, and then we pass it on to here. So we have to also bear that in mind. So many times there are no need for type conversion, but sometimes you have to. We should bear in mind. I have the next bit coming up. Yeah. So this part, yeah, I mean this part, we look at the user inputs, yeah. So we've actually done a little bit something before that, yeah, by using the console.read line here. Yeah, so we have already learned the write line. So the write line is used obviously to print out to the console. Now we have to look at the console.read line to get the user inputs. So as you can see here, I have the user, I requested the user to enter their age. So once the age is entered, yeah, it actually entered on the console as a string. So we actually read it as an integer. So by reading it, we actually convert this, because it returns as a string, into an integer straight. So our age becomes an integer straight away. Oh, we could just do with something like this here. String C read for like console read is equal to console.read line. So if you look at this here now, so the C read is now our test. So we could actually remove the console.read line here altogether. So we can put our C read here, the console read, and we should get the same results. So we could just F5 it here. So you just enter age. So your age is 54. So you see nothing has really changed. So the console.read line method returns a string. Therefore, you cannot get information from another data type such as int. So the following program will cause an error. So let's say um, let's say age is equal to console the real line. So as you can see, we have, an error here. If we look at it here, see, cannot implicitly convert type string into an integer. So this is all we've been talking about. So you cannot do it that way. Before we go ahead, yeah, if you enter the wrong value as an input, you will get an exception, something like system.format exception. So there's this new word comes into mind, exceptions. But don't worry about that. We're gonna have a look at it later on a later part. So don't get too bothered about it. Yeah. So we go ahead with the next part, which is the C# operators. The operators are used to perform operations on the variables and values. So in a case like this here, I'm just gonna go all the way down here and remove everything here. So we're still gonna use our integer. X is equal to 200 plus 354. So as you can see here, the plus operator is often used to add together two values, like the example that I have on the screen. It can also be used to add together two variables and a value, or a variable and another variable. So we go ahead, we get to it again. Yeah. So we passed another integer y, which will be equal to 320 plus 500. So as you can see, we can have another third integer, str. I'm just using any name. That will be x plus y. So as you can see, we can add two variables, or we can add two variable values. And we look at arithmetic operators. So as you can see, we have two values here. This is the plus is the addition value. So if we want to make any subtraction, this is what we do. We use this dash sign. If we want to do multiplication, we use the star. And division, we use the / for division. Should bear all that in mind. And the modulus, we use the percentage sign. What is a modulus? Modulus is the remainder, returns the division remainder. We get to it later on. And there is an increment which increases the value of a variable by 1, which is a plus plus. And a decrement, which is minus minus. You look at the C# assignment operators. Assignment operators are used to assign values to variables. We use the C#, the plus operator is used to assign values. And then the addition assignment operator adds a value to a variable. So in this case, let's say now we have the store variable here now. We're just going to put an add here. We're going to make it an addition. Yeah. So to have an increment or additional increment to the store, we could say store plus equal sign 200. Yeah, that means whatever value that we have here already, we're just gonna add a 200 to it. We could actually run it here now. So we can put our store and with F5. So whatever the value was for the store, we actually added. Before we, okay, there's one thing I'm gonna do. Before we actually print out this here, you're gonna print it out again before that, before the assignment increment. So we're just gonna run it again. So as you can see, the first one is 1374. And then once we added the 200, we get 1574. So this is just to add 200 to the value of this. So we should bear that in mind. And then we have an assignment decrement as well. So instead of adding this, we could put the minus here just to take out the 200 from it. So we could just run it again. So as you can see, the 200 has been taken out of this. So there are lots of assignment operators in a C# language. And now we could look at the comparison operators. They are used to evaluate two values, or to evaluate the truthfulness of statements. So we just we're going to remove this bit here after here. So there is the two equals operators is used for equality. So we can say if S is the same as Y. So what we're trying to say is if X is equal to Y, then there's something that you could do. Then we could say S is equal to Y. But if that's not the case, then nothing will show up here. So we could actually run it, which I guess nothing will show up because they are not the same. So as you can see, nothing showed up. But we could do the not equal. So if X is not equal to Y, we could just do this bit here, put a exclamation and a plus. So in this case, we could just say, you see that we put this bit here, S is not equal to Y. So basically, the statement will return true if S is not equal to Y. So we can just run it and see. So as you can see, X is not equal to Y. So we can actually print out the values. We put our $sign here. Then we bring our curly brackets here. We can say X. So in this case, we print out the value of the X and then the Y. We print the value of the Y here as well. So as you can see, pretty straightforward. So now we could just say console.writeline. You can just run it to see. So as you can see, 554 is not equal to, we all know that 820. So that's what we have here. So yeah, the next bit is there's a greater than sign. It's the same as that mathematical term. So we can say if x is greater than y, then we will say x is greater than y. Otherwise, nothing will be printed out anyway. So we just gonna restart it. So in this case, I think nothing will be printed out because the conditional evaluation returns false, so nothing pops out. So as you can see, there's nothing printed out. So now we go to if x is less than y, which something will pop out. So if something is, if x is less than y, so now we should expect something to be printed out. So as you can see, 554 is less than 820. So there's a things that obviously now we could say less than or equal to. So that you're just gonna leave the less than sign and then we add an equal to sign to it. So you can say that x is less than or equal to y. So if that's the case, the test will be printed out. If not, then it won't. So as you can see, 554 is less than or equal to 820. So we could do the same thing for this part. So you can say, yeah, if x is greater than or less than y, or equal to y, and we can print out something. If nothing comes out, if nothing is printed out, then we know the statement is false. So the statement is false, so we've got nothing. So as you can see, it's very simple and straightforward stuff. And now we're going to be looking at the logical operators. They are used to determine the logic between variables and their values or values. So, and this can also be some logical statement, right? So I'm just going to make an examples of some logical statements, right? So here, this is just to evaluate two operations. So here, we can say if s is greater than or equal to y, and then we have this bit here. These two characters is an AND logical operator. This showcase that both sides should return true. So we could say x less than y. Y. So you see, so if this part is true and this one is true, then we will get this printed out. Yeah, but if one of them is false, nothing will pops out. So let's run it. So as you can see, nothing was printed out because we know that this one is false, but this one is true. But even if this one is false, there's something more we can do. That's what it's called the logical negation. So we put a parenthesis here. I mean a bracket here. We put a thing back in here. It's still false, but we can actually negate it by using the exclamation. Yeah. So now, though this one is false, we've actually negate. So the negation of false is true, right? So this will become a true statement on its own, and then this will become a true statement. So this should be true and be printed out. It's because we've actually negated the false. So as you can see, we've got it printed out. So this part is a little bit tricky. So you should be very careful. Yeah. Here, this expression here returns false. Yeah, it's a false statement. So with this, only this and this is a true and this is false. But this logical operator only evaluates the truthfulness of both sides before it returns. So this this part should be true and this part should be true. So though this one is false, with the negation of false is true. So we've actually negated the false to become true. We can do this by making this part less than. So less than. So you see the negation, this part is true. So the negation of true is false. So if we leave the negation here, nothing will work. So I'm just going to print it out for y'all to see. So as you can see, it never worked because though the statement was true, we've actually negated it to false. So before we can get the both sides to be true, we have to remove the negation, which is the exclamation sign. So now it is true. So once we actually run it again, it will be printed out. So you see that? So it's this part, yeah, it can get very tricky, yeah, because you can write a very complex statements and using the logical operators to just figure out where to go, right? So yeah, we've actually looked at the and operator. Now let's look at the logical or. In this case here, so you see this part is supposed to be true and this part is supposed to be true, but in this case here we just need one part to be true. So we use this is the sign for the logical or. So in this scenario, either this or this should be true for the whole thing to be returned true. If they're both if they're both false, nothing works out, nothing checks out. If they're both true, it still works out. So now we have both true here. So let's actually run it to see. You see, it still works out because they're both true. Yeah. Let's negate one of it to a false. So we put our exclamation sign here now. So this part here is now a false statement, but this part is true. So because we've got one true statement inside the expression, it's still gonna run. So we're just gonna actually so as you can see, it's still running now. The only time it doesn't run is when we have both side of the expression to return false. So let's say we have a negation of this bit here as well, and a negation of that bit here. Then the whole statement, this part is false and this part is false. That means the if evaluation returns a false statement. So we should bear that in mind. So yeah, so we have the logical NOT, which we've actually looked at. Yeah. So it's the reverse. It's to reverse the results. returns false statement if the result is true, like what I've done here later on here. So this is the logical NOT. So if this is true and you want to make it as a false representation, then you have to put the exclamation sign here. So we just move on again. So I hope you understand all this part of it. It's a very, like, you need to you have to do a little bit more exercise, yeah, to understand it better. Or you can just make the numbers very simpler to analyze, yeah, like 200 and 320, so that you understand it straight up, the values, yeah. So yeah, we're gonna move on to another part, yeah, or another aspect of what we're actually doing. So we look at the mathematical, handling mathematical expressions and mathematical, perform mathematical tasks in C# language, yeah. So here, I'm just gonna remove this bit here. Okay, so the math class has many methods that allows you to perform mathematical tasks on numbers. Yeah. So we have the math.math method can be used to find the highest value. So let's say I have x variable x, which is okay. Let's put an integer here. We've got x, which is 20, and y, which is 30. So now we will just gonna run this bit. So we look at the math class here. First, we will create like two integer variables. Yeah, x is equal to 20, y is equal to 30. Yeah. So here we're gonna write this to console. We have a variable here, which is res for results. Then we use this math class that has got like a lot of mathematical operations in it here. So we're gonna start with the math. This evaluates two integers and print out the maximum. Yeah. So here we can just say CW, which is console the right line, the res, just to print out the value. In this case, we all know that because we have a predetermined value, which is 30. So I guess the 30 will be printed out. So as you can see, it's 30 printed out. So there's one more, which is the minimum. So if we have the mass, we should have minimum. So this also print out the minimum, which I guess is the x, which is 20. Well, you see it's 20 printed out. Yep, so we just move on. Then we have a square root. Yeah. So we're just gonna put this bit here. An int value. Say 36. So we look for the square root. The square root is sqrt to get the square root, and it's a 36. Yeah, so we get the square root of a 36. That is 6. So you see, that's how you get the square root of a number in C#. Yeah. So abs returns to the absolute positive value. Yeah. So we can just say dot abs. So we can just say minus blah 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 dot 90. So we're gonna see what comes out of it here. This will explain it. So as you can see, it's 1232.9. So it only just returned the positive, the absolute positive value of the number or of the value. So we should just bear in mind the ABS is for absolute positive value. Okay, round. The round is to round a number. So we're just gonna make it 12. And remove the minus. So here it's math.round. So we're just gonna round it the 12.90 up. So we started here. As you can see, it's a 13. It returns 13. So the round returns an integer value, right? Or a double value, whatever. So yeah, this is what we've got down for the mathematical side. Yeah, we've got the basic mathematical operation. So you can just have a look at what you can actually do, because there are lots of stuff you can get. Pi. You can get your pi value, which is a constant. You see that? You can get your mass, minimum, abs, round, square root, a cos, a sin, a tan, a tan 2. There's a whole lot of stuff that you can do with it. Yeah. So I'll leave that to you for y'all to just like keep it going. Alright. So yeah, we move on to the next bit. Which is what is string? Strings are used for storing text. We're just gonna look at strings in C#, which it can take as like its own chapter. So string variable contains a collection of characters surrounded by double quotes. So it's very easier to create a string, like we actually looked at earlier on. You can just use a string keyword st, and you assign a value, double quotes, and you can put your string inside the quotes. That's as easier as you can get. That's how you actually create a string. So there are some the string has some extension methods that you will actually gonna need, or you'll be able to make use of. Yeah. So there's a string concatenation, right? You see, how we added two numbers together, or how we added a number to a already valued, already number of a variable. We can add a string to a string by using that. So we add and then equal sign. Then we can add a string. Yeah, so we could just say, leave a space here, world. Yeah. So basically we've added a world to the value of to this st. So if we print it out here, st, we should get hello world. So we F5. As you can see now, we've got the hello world printed out now. Yeah. So basically, this is adding strings together is called a string concatenation. Yeah. So you can also do it like we can also add two strings using the additional sign. Yeah. So we have string st1, and we have another string st2, which is So we forgot the equal sign to assign it. So yeah. So now what we could do is we could just say we could just say we're just gonna leave some space here. We can just say console the right line. So inside the console the right line, we could just say st1 plus st2. So we just concatenate the two strings to become one. So we could just say string st3 is equal to st1 plus st2. So it is pretty much the same as what we've actually done inside the console. So we're just gonna run it to see what comes out of it. So as you can see now, hello crazy world. Yeah, that is how you can just put two strings together. As you can see, it is very simple. But you could also you can also add an integer to a string. Also, you could directly add an integer to the string concatenation. So we're gonna say plus x. So in this case, yeah, it will just add the x, and that will be a string. So we run it again. So see, I need to put inside here the st3. Sorry, inside the right line, I'll put the st3. That's where I've got the x added to it. So I'm just gonna run it again. You see, so hello world, hello crazy world 2019. So you see how simple that whole thing is, yeah. And then there's there are some extension methods that we could actually make use of, yeah. So in this case, yeah, we could actually convert our string to the all caps, yeah. So I can just say dot to lower. So this will actually convert it all to lower cases, yeah. Because they're all lower cases, it's not important, yeah. So we will convert, yeah, the st3. We copy it, we paste it, put them in a something like this, and then we copy it to upper cases. Yeah, so now we have the S. I'm gonna remove the to the lower here first. So now we've converted it to capitals. Yeah. So to upper is to convert it to the capital letters. Yeah. So as you can see, we've converted all of them to capitals. Yeah. So it's very simple stuff. And then inside here, to convert them back to lower characters, we could just say dot to lower, and there we go. So it will be converted back to the lower characters. So that's how you convert it back to the lower characters, yeah, dot to lower. So yeah, this is something that is very simple. I'll end this part by talking briefly about string interpolation. Another option of string concatenation is string interpolation, which substitute values of variables into placeholders in a string. Yeah, which is something I've done previously. Yeah, but I'm gonna do that again. So I'm just gonna remove this bit here, all of them. I'm gonna remove this bit here. So you can put that inside. I'm just start with a dollar sign, yeah. Hey guys, today's date is, and we use the curly braces inside. So we're just gonna put our daytime dot UTC now. Then we convert it to a string. So whatever string that we want it to be. So as you can see, we've been able to put so chili, something like that, you know what I mean? So it's very simple stuff. So we can just get the whole thing. So as you can see, we've been able to insert the daytime, convert the daytime here into our test. So that's actually called a string interpolation. So bear that in mind. So first, but I mean, to be able to get down with this part here, we will look at how you can access a character inside a string. That is also very simple stuff here. I'm just gonna remove this bit here now. You can do that by getting the index of that character. So string st is equal to hello world. So you can actually access the character using the indexer, which is the square bracket. Then you put the value. The first value, of course, is 0. So the first character, H. So in this case, we're selecting the first character. Yep, so as you can see, we've been able to select the first character of the string by using an index. So it's very simple stuff. So what I'm gonna do is I will leave this bit here. This tutorials here. I've got a couple to cover, so I will actually do that on the next video. I got a couple more. On the next video, we will look at the booleans, the if-else statements, switch statements, the while loop, for loop, the break continuum, and the arrays. So, if you haven't subscribed to the channel, I really urge you to do so because I've got lots coming up. But if you have, stay tuned and stay blessed. Catch up later. Have a lovely day, morning, afternoon, wherever you are. Peace.